All right, this is for the topic understanding functions. Let's get into it. Before we actually do any problems, let's make sure we understand what is a function, what is a relation, and all of this stuff. So first things first, a relation is a set of data that corresponds to another set of data. The way that you see this all the time is in the form of X and Y pairs, ordered pairs, coordinate planes with points on it, things like that. So if I just gave you a random list of numbers, if I was like 5, 7, 13, 12, 29, 82, are those two sets of data that are corresponding to each other? No. So it's not a relation. Okay, this is not a relation. It's just a single set of data. There's no one thing corresponding to another. There's no one set of data that corresponds to another. A relation is when you have two sets of data corresponding to one another. So it's not a relation. Every function is a relation. So if it's not a relation, it's also not a function. So let's get that out of the way. Now let's put together a set of ordered pairs. Let's say I have a 5, 8 and a 3, 6 and 12, 19 and 13, 22 and I don't know, 17, 57, whatever. I've got a bunch of X and a bunch of Y coordinates. So I have two sets of data. I have X's that corresponds with Y. So this is a relation because we have X and Y coordinates. Anytime you have X and Y coordinates, you have a relation. So before we move on, let's look at our first problem. Which of the following describes the following graph? Well, I've got 4 points on this coordinate plane. Those points have X and Y coordinates. So this is a relation. So I'm looking at my options. I want the one that says that it is a relation. Now, I don't know yet if it's a relation only or if it's both a function and a relation, but I know C and D are not answers because it definitely is a relation. So C says neither function nor relation. That's not true. This is a relation. We have X and Y coordinates put together, and it's not a function only because, again, it is a relation. So it's going to be either a relation only or both a function and a relation. So now what's a function? A function is a relation where every input, which are the X values, when you look at a relation, the X values are the input, where every input or every X value has one and only one output that corresponds with it. So I look at this relation. What does 5 correspond with? It corresponds with 8. It has to always correspond with 8 for it to be a function. 5 cannot correspond with any other Y value. I can't have another ordered pair and have 5 with a different number other than 8. The same thing goes for 3 and 6, 12 and 19, 13 and 22, 17 and 57. None of these numbers can have another output that it corresponds with. So right now, this is a relation and a function because each of these only corresponds with one particular output. But if I were to add another point in here, let's say I added the point 3, 18. Well, wait a minute. Here, the input 3 corresponds with the output 6. But now the input 3 also corresponds with the output 18? That's not okay for it to be a function. It's still a relation, but it's not a function now. So now let's look over at our problem. We have 4 points here. Well, the input, the X coordinate of each point, you can tell this X coordinate is -6. And what's its output? -4. So if I was going to write that down, and it's not necessary to write them all down. I'm going to show you a shortcut in a minute. But our points on the graph are -6, -4. This point right here is 0, -2. This point right here is, I'm sorry, that's 0, -2. This point right here is -2, 0, excuse me. And then our last point over here is 4, -6. So let's look at our X inputs. We have -6 corresponds with -4. 0 corresponds with -2. -2 corresponds with 0. 4 corresponds with -6. Did any of these X values repeat themselves? -6, 0, -2, 4. Did we get one that happened twice and corresponded with a different Y value? No. So this is a function and a relation. Now I said I would show a shortcut. You don't have to write it down every time. You just have to look at the graph. What would happen if we added another value that had a similar x input? For example, let's say we added another one that had an x, had an input of 4, let's say. Let's say we also had 4, -3. This would make it not a function anymore because 4 corresponds to -6 and 4 corresponds to -3. How is that a shortcut? What would that look like on our graph? Where would the point 4, -3 go? Well, it'd be 4 and -3. It'd be right there. Notice that that point would be directly above a point that's already on our graph. If you have 2 points on your graph that are right above each other, that means they have the same x value. And that means they have different outputs. So the same x value with 2 different outputs is a no-no, and that would make it not a function. So if you're looking at a graph to determine if it's a function or not, just see if 2 parts of the graph are vertically right above each other or not. If you can draw a straight line up and down, a vertical line, and it touches 2 parts of the graph at the same time, then that is not a function. But this one is a function. So consider the table below. We have input 0, 1, 2, and 3 corresponding with output 9, 7, 5, and 3. Which of the following graph correctly shows the above function? Well, let's take a look. Where's 0, 1? Which one of these graphs has 0, or excuse me, not 0, 1, 0, 9 on it? X and Y, 0 and 9. So W, 0, 9, X, that's not 0, 9 at all. Remember, X values go left and right, Y values go up and down. So it's not this one. This one has 0, 9, and this one has 0, 9. So it's definitely not X, but it could be W, Y, or Z. Let's find 1, 7. 1 on W is right here. 7 is right there, so it's not W. Let's try this one. 1, 7, that works. And this one, 1, 7. Oh, nope, it doesn't work. This is the only one that hits the first 2. It should also go through 2, 5, and 3, 3, and there it goes through 2, 5. And there's 3, 3. So it's graph Y. That you should know how to do. If you know how to read a table, X and Y, and look at a coordinate plane, you can tell which graph belongs to which one. Which of the following represents a relation that is not a function? Okay, so now we're looking for one that's not a function. We're looking for one where an input has 2 different outputs. So let's take a look at the first one. What are our inputs? -9, -5, +5, and +10. None of those inputs repeat themselves. We don't have one input that shows up more than once. So this is okay. -9, -5, -1, and +3. Again, no input shows up more than once. So no input has more than one output. What about C? -9, -5, -9 again, and +3. That's a problem. This says that our -9 input has an output of 33. And it also has an output of 39. -9 corresponds with 33, and -9 corresponds with 39. That's not okay. This is the one that is not a function. Just take a look at the last one just in case. 5, -5, 10, -9. None of those repeat themselves. Notice that I don't care that the Y values repeat themselves. It's okay for 2 different inputs to have the same output. So like -9 can correspond to 33, and so can 10. 10 corresponds to 33, and so does -9. That's fine. 2 different inputs can have the same output, but you can't have one input have 2 different outputs. So again, this one's okay. All these other ones are okay. This is the one that's not a function because the X value, -9, shows up twice with 2 different Y value outputs. Which of the following matches the following graph? This is just reading tables again and reading a graph. Again, input is the X-axis, output is the Y-axis. So let's see, where's that dot? That is at 1, halfway between 0 and 2, and 0. So which one says 1, 0? A does, B does. Not C, not D. That would be 0, 1, and 0, 1. That would be the other way. 0, 1 would be right here on the graph. That's not where we want it to be. 1, 0. Next, 2, 5. Which one says 2, 5? They both say 2, 5. Okay, what's the next one? 4, and up there is 15. This one says 415. This one says 410. Not 410. 410 would be right here. That is not where we want to be. So 415, and then we could just double check it, make sure we didn't make a silly mistake. 625, but they both say 625, so it's definitely A. Which of the following best describes the equation below? Y equals 4. Now, this is a little bit of a trick question. It's a little bit of a trick question. Let's look at this. If you have x and y values, I told you it's a relation. And you might look at that and go, hey, there's no x and y values. There's only a y value, so it's not a relation. But it's kind of a trick. Imagine the equation that we've used multiple times before, y equals m times x plus b. If y is equal to m times x plus b, and I have y equals 4, is y equals 4 in this format? You might think, no, there's no m or x or anything. And the truth is, it actually is. Imagine if your m, your slope, was 0. Then you would write, and imagine also that your b, your y-intercept, is 4. If you were going to plug these two numbers into this equation, it would say y equals 0 times x plus 4. Well, what is 0 times x? It doesn't matter what x is. 0 times x is 0. So we'd have y equals 0 plus 4. And that would be 0 plus 4 is 4. So you get y equals 4. So this y equals 4, what we started with, is actually this equation in slope-intercept form. So if I wanted to plug in values for this equation, what could I plug in? Well, let's plug in, 1. 0 times 1 is 0, plus 4 is 4. So if I plug in 1, I get out 4. What if I plug in another x value? Say, negative 7. 0 times negative 7 is 0. 0 plus 4 is 4. If I plug in 3, I'm going to get out 4. If I plug in 9, I'm going to get out 4. If I plug in 20, I'm going to get out 4. So these are all the points that we've gotten so far. It's going to keep going this way. No matter what we plug in for x, we're going to get 4 for y. So let me ask you a question. Does every input have one output? Yeah, every input is only going to get out 4. It doesn't matter that the outputs repeat themselves, like I mentioned on that earlier table. It's all right if multiple inputs have the same output. What's not okay is if we get 1, 4, and then later we also get 1, 5, or something like that. But every time I plug in 1 to this equation, there's no other way I can get anything but 4 to come out of it. So this is in fact a relation, and it's also a function because every input has its own output. That's going to be true for any equation that simply says y equals whatever. It doesn't have to be 4. It can be y equals anything. It is a relation and a function. Number 6, select the correct answer from each drop-down menu. Complete the definition. A blank, we have relation and function, is a relation or function where there is exactly one unique input or output for each input or output. So a function is a type of relation. It's a relation where there's exactly one unique output for every input. Every function is a relation where every x value has exactly one y value that goes with it. So there's one y value, one output for each x value for each input. Which of the following best describes the equation below? I have y equals negative 7 times x plus 9. This looks a lot like what we just did a second ago, y equals mx plus b. Anything in that format is going to be a relation and a function. As a matter of fact, if you don't see any exponents, you're pretty safe in saying that it's a relation and a function. The only time that you're going to get an equation where you don't have a function is when you have your y being squared or raised to another exponent. But your x can be raised to different exponents, and that's okay. So this is going to be a relation and a function. If we were to graph this, it would be a straight line. Every x value, no matter what I put in, I'm going to multiply it by negative 7 and add 9. There's no way to do that differently more than once. So every time I do it, it's going to get the same thing out. All right, so let's take a look at this graph. Well, what's going on here? First of all, do we have x and y points? If you have something on a coordinate plane, you have x and y points, that means you have a relation. So this definitely is a relation. But is it a function? Well, let's take a look at some of these points. Right here, that would be the point negative 3, 0. So negative 3, 0. Start with that. Negative 3, 0. What's another point on here? Let's say up here. Well, that's negative 3, 6. And what about like down here? That's negative 3, 4. If you haven't gotten the gist already, every single point on this line has an x value of negative 3. but they have different outputs. They have different y values that correspond. So the input -3 has different y value outputs. That's not okay for it to be a function. So this is a relation only. And again, the shortcut is, are multiple points on your graph one above each other, one above one another? And yeah, they're all right above each other. It's a vertical line. That's the entire graph. If you have 2 points on the graph, and this has an infinite number of points on the graph, but if you have 2 points on a graph that are right above each other, then it's not a function. And this, every single point on the graph is right above each other. It's not a function at all. But it still is a relation because you have these points on the coordinate plane. Which set of ordered pairs is made up of points on the graph of the function below? Well, this is pretty easy. We have an equation and we have points. So all we have to do is figure out which sets of points go into this function. So the first thing is, let's just take a look. If you have -1 for an input, these both have -1 for an input. Let's see if that works. Y equals -4 times x plus 8. Let's go ahead and plug that in. If you have y equals -4 times x plus 8, and you want to plug in that x is equal to -1, then you get y equals -4 times -1 plus 8. So y equals -4 times -1 is +4. So that's plus 8. So y equals 12. So when x was -1, y was 12. So -1, 12 is one of the points on our graph. And we have A and B. Now, that doesn't necessarily mean that 12 -1 is not one of our points, but we're assuming that they're trying to trip you up here. And if I just do a quick kind of common sense, -4 times 12 is -48. -48 plus 8 is -40. So C and D are not anywhere close. Let's try the next one. We have 8, 0 and 0, 8. Well, anytime that you have this format, y equals mx plus b, b, the thing at the end that we're adding on, is whatever y is when x is 0. So x is 0, y is 8. This is going to be your answer. Right away, it's the only one that had that. When x is 0, y is 8. And it also had our first point right. If we plug in the rest of these, it will work. -4 times 1 is -4. -4 plus 8 is +4. And -4 times 2 is -8. -8 plus 8 is 0. If you want to write that out for all 3 points, you absolutely can, and you'll check them out. Okay, so now we have another, oh man, this is a crazy looking graph. Well, it's all right. It's asking a real simple question. Is it a relation, a function? Is it both, or is it neither? First of all, do we have points on a coordinate plane? Yes, so it's a relation. So it's automatically either A or D, because it is a relation. We have points on a coordinate plane. Next, is it a function? Do any points on this graph appear right above one another? Are there any points on a graph where, hey, that point is also right above that other point? No, each one of these points, each input has its own output. No matter where you go on this, let's say I went right here. Well, this is where my x input is 4. If I went straight up or straight down, there's no other points where x is 4. And that's true for this entire thing. So this is a relation and a function because there are no 2 points that are directly above one another, meaning no 2 points have the same input but different outputs. So this is a relation and a function both. All right, if you get any more types of questions that you want, I'd be happy to help you out with those. So let me know if you have any other questions, if I missed some certain types of questions that you didn't understand. I'm going to go ahead and just do a few more of these. If you've got enough information, feel free to stop the video and go on and keep doing it. I'm just going to do some more just to make sure. If you want to see some more examples, then I'm going to do some more examples. And here's a great other example. Which of the following describes the graph below? I see 4 points, so I see a relation. But look at these 2 points on the left side. They're right above one another. They're right above one another. That means they have the same input. Their input for both of these is -5, but they have different outputs. The x-coordinate of both these points is -5, but this is -5, +3, and this is -5, -4. There's no way that I can have the input -5 have 2 different outputs and it still be a function. So this is a relation only, not a function. Which of the following best describes the ordered pairs listed below? Is this a relation, a function, both, or neither? Well, again, we have x and y points, so it's a relation. Do we have any repeating inputs? Absolutely we do. Look, -4, 0, And then later we have -4, -22. So the input -4 has output 0, and then later has the output -22. That's not okay. Every x coordinate can only have one corresponding y coordinate that goes with it if it's to be a function. So this is not a function. It is a relation, though. Any set of x and y coordinates together is a relation. Which of the following best describes the graph above? Well, we've got lots of points here that are right above one another. Let's take a look at, see this point right here. This is 2, 2, but it's right above this point down here, which is 2, -6. So those points both have an input of 2, but two different outputs. So right away, this is not a function. There's lots of points. Any 2 points that you both right above each other prove that this is not a function. And this happens all the way down, all the way across. So this is a relation because it's points on a coordinate plane. It's x and y values, but it's not a function. It's a relation only. Which of the following best describes the graph? This is a relation only. Again, we have 2 points that are right above each other. This one right here is right above this one right here. So they both have the same input. In this case, the input they both have is 0, 0, 3, and 0, -3. Relation only. This one, it's a flat line, but it's okay because there's no points right above each other. So this is a relation and a function. No two inputs have the same. No input has two different outputs. This one, no points are right above each other, so that is a relation and a function. Okay, consider the equation below, y equals 5x minus 6. Complete the tables of values for the equation, and then determine whether the equation represents a function. So here we go. Y equals 5 times x minus 6. What if y is -26? Let's go ahead and write an equation. If y equals 5x minus 6, and we get y is -26, we can simply substitute that in. So -26 is equal to 5x minus 6. Now we have to solve. Plus 6 on both sides. -26 plus 6 is -20. That is equal to 5x. Now we divide by 5 on both sides. Divided by 5, divided by 5. And we get that x is equal to -4. So when y is -26, x is -4. What about if x is -1? Again, we've got y equals 5x minus 6, and now x is -1. So y equals 5 times -1 minus 6. So y equals 5 times -1, which is -5 minus 6. So y equals -11. So when x was -1, y was -11. And one more. What happens with the same equation when y is 9? So we have, again, y equals 5x minus 6, and y equals 9. So substitute the 9 for the y. 9 equals 5x minus 6. Add 6 to both sides. 9 plus 6 is 15, so we get 15 equals 5x. Divide by 5 on both sides. We get 15 divided by 5 is 3, so 3 equals x. So we get 3. So does the equation represent a function? Yes or no? Yes, it does. Every time we plug in an input, we are going to get the same output for that specific input. We're never going to plug in something for x and get two different answers unless we do our algebra wrong. It is a function. Which of the values matches the following graph? So this is just matching up points with the coordinate plane. We have 2, 8. There's 2, 8. There's a 2, 8. That says 8, 2, and that says 8, 2. 8, 2 is way over here. That's definitely not it. So it's either A or B. They both have 4, 12. So the next one I'm going to look at that's different is 6, 14 versus 6, 16. So let's go over to x6, and we go up, and we see 16 is where it is. So 6, 16. Which of the following best describes the equation below? Y equals the absolute value of x plus 5. The absolute value of x plus 5. What does absolute value mean? Absolute value is how far away from 0 is this point. So if you want the absolute value of a number, you just make it positive. If it's negative before, you just make it into a positive because -3 is 3 spaces away from 0. And if it's positive already, then you're good. It's still positive because 3 is 3 spaces away from 0. You don't have to change anything. So let's look at y equals the absolute value of x plus 5. Give me a number I might plug in for x. Choose one. Well, what's the easiest one? 0. So let's say x equals 0. Y equals the absolute value of 0 plus 5. Well, the absolute value of 0 is 0. 0 is 0 spaces away from 0. So you have 0 plus 5, so y equals 5. So 1 point is 0, 5. Okay, let's try another point. How about y equals the absolute value of x plus 5 when x is, say, I don't know, 4. Well, then y equals the absolute value of 4 plus 5. So y equals 4 plus 5, because the absolute value of 4 is 4. And 4 plus 5 is 9. All right, well, how about y equals the absolute value of x plus 5 when x is a negative number, say negative 7. Well, then y equals the absolute value of negative 7 plus 5. The absolute value of negative 7 is positive 7, because negative 7 is 7 spaces away from 0. So the absolute value of negative 7 plus 5 is just 7 plus 5. So y equals 12. So if I plugged in negative 7 again, I'm going to get out 12 every single time. If I plug in 4 again, I'm going to get out 9 every single time. If I plug in 0, I'm going to get out 5. There's no way when I plug in x for it to be more than one thing. What's going to happen in this type of equation if you tried to plug in something for y? It would be a little goofy. For example, if I said y equals the absolute value of x plus 5, and I said, what if y is, I don't know, 13? Well, then I would say 13 is equal to the absolute value of x plus 5. And then I would subtract 5 from both sides. And 13 minus 5 is 8. So 8 equals the absolute value of x. Well, how do I solve that? You may not have a lot of experience with solving absolute value equations, but it's pretty simple if you just remember what absolute value means. Absolute value is how many spaces something is from 0. So you're asking yourself, which numbers are 8 spaces away from 0? So what you would say is that if the absolute value of x is 8, then x equals the positive version of that, which is positive 8, or x could also equal the negative version of that, which is negative 8. So it turns out that if I input 8, I'm going to get out 13. And if I input negative 8, I'm going to get out 13. But that's okay, because it's two different inputs getting the same output, and that's all right for it to be a function. It would be bad if I had two different outputs for one input, but it's okay that one output has two inputs that get to it. No matter what, if I plug in negative 8, I'm going to get out 13. If I plug in 8, I'm going to get out 13. If I plug in negative 7, I'm going to get out 12. If I plug in 0, I'm going to get out 5. If I plug in 4, I'm going to get out 9. Every input has one output. That's okay, even if one output has multiple things that will get to it. So this is both a relation and a function. One more. This is just checking the table on the graph and seeing what's what. 0, 1. Which one's of 0, 1? W, 0, 1. That would be 1, 0 right here, this point, so that's no good. Here's another 0, 1, so graph Y is okay. And Z is a no-no. That's a 1, 0. So it's either graph W or graph Y. The next point is 2, 3. Here's 2, 3. So it looks like W is our answer. Let's go over here and check 2, and it only goes to 2, 2. So it's going to be W. It's 2, 3. We could check 4, 5. Absolutely. And 6, 7 as well. Yep, right there. So graph W. Hopefully this is enough problems for you. Let me know if you have any other questions, and I'd be happy to send you some help. If you have a specific question that you come across that you want help on, email me. Let me know exactly what problem it is, and I can look at it for you and send you some specific advice. That's all.